In this video, I'm going to walk you through the Python codes of training the random forest regression model in my project. Firstly, I import modules that are gonna be used, which include NumPy, pandas, and sklearn. Next step, I import the data as a data frame by using the pandas read Excel function. Data are carbon fluxes and associated environmental variables from Flux sites. The variable net ecosystem exchange of carbon, NEE for short, will be used as the response variable, while incoming shortwave radiation, air temperature, soil temperature, wind speed, vapor pressure deficit, soil water content, water table depth difference, and the site will be treated as predictors. You may notice that there are two predictors, month and season, missing in the original data. No worries, I will create them later. And due to sensor failures, there are some gaps within the data which cannot be handled by the random forest regression model. Typically, random forest encourages two ways of handling missing values. The first way is to drop data points with missing values, but this way is not recommended, especially when the amount of data is small and the proportion of missing data is high, as in our case. The other way is to fill in missing values. Therefore, in this study, these gaps need to be filled before training the model. Here shows the codes for creating new predictors. I write a function, future engineering, to create new predictors, month and season, from the variable date. Of course, you can also directly derive the month and the season from the variable date instead of writing such a function. Then, I divided the data into predictors, which are denoted as X, and the response variable, denoted as Y. After that, I split the dataset into train, validation, test datasets with a ratio of 0.7, 0.15, 0.15. As I mentioned earlier that there are some gaps within the predictors, and the random forest regression model cannot handle missing values. I have to fill these gaps before training the model. Again, I write a function impute missing to impute missing values using iterative imputer. Actually, I tried multiple imputation methods, including the commonly used mean, median, and the regression imputation. It turned out that the iterative imputer, one type of the regression imputation methods, works best. And after the imputation, there are no more missing values in the data. Now, we get all the predictors without gaps, but there is still one thing to be aware of is that there are three variables, site, month, and season, being categorical variables. These categorical variables need to be one-hot encoded. One-hot encoding technique is specifically used for categorical variables where order does not matter. Okay, there is still one last thing before training the model, which is the data standardization using the standard scalar function. The idea behind the standard scalar is that variables that are measured at different scales do not contribute equally to the fit of the model, therefore could end up creating a bias. After the above-mentioned data processing, now we can train the random forest regression model. Here, I use the grid search CV function to tune hyperparameters of the random forest regression model. Hyperparameters are parameters that are not directly learned within the data, so we have to tune them to determine the best sets of hyperparameters for the model. Grid search with cross-validation is a widely used way to finely tune these hyperparameters. In this case of a random forest regressor, hyperparameters include the number of decision trees in the forest, the number of features considered by each tree when splitting a node, etc. In this project, grid search CV results suggest that a random forest regressor with bootstrap, maximum depth being 16, maximum features being auto, minimum samples leaf being 1, minimum samples split being 2, and the number of estimators being 2,000, results in the best accuracy. The accuracies on the training datasets and on the validation datasets are both 0.7, while on the test datasets being 0.68. Also, we can call CLF, which is the trained model, dot feature importance to rank the relative importance of each predictor. Here in this study, the top 3 important variables on NEE are incoming shortwave radiation, soil temperature, and water table depth. Furthermore, we can also use the matplotlib module to visualize the variable importance to make the results more intuitive. So that are all the codes I used in the project for training a random forest regression model. Hope you find this code walkthrough video helpful. Thanks a lot.